Okay, so here we present a new algorithm for modulo sampling recovery. So the message here is that for the previous R, we have two types of modulo recovery algorithm. So here the problem is about the high dynamic range signal sensing. We may have a compromise between high deep signal dynamic range, which may be clipped or saturation, or we can somehow shrink the dynamic range. To set the dynamic range to be very large, but we may lose the digital resolution. So here we have a USF, the hardware devices. The key message here is that before point-wise sampling, we fold the signal into a fixed dynamic range, like this one. By this one, we have fixed dynamic range, and we have higher digital resolution for free, independent of the input signal. But the problem is that how to get the signal recovery from the modular samples. Previous algorithm, they can be divided into two categories: a time domain and frequency domain. Both of them, either they suffer from the spectral leakage, or they are not robust enough to the noise, bounded or unbounded. So here the message here is that we have a new model to characterize the modular samples. We use the sparse parametric representation to characterize the piecewise constant signal here. So by utilizing the signal structure, one is band-limited for this one, another one is a piecewise constant, which is sparse in nature. We have two different signal structure, so we have designed the alternative optimization strategy to keep iterating the signal estimate iteratively to get a much more robust signal reconstruction. So here we show the hardware data validation. First one is a normal one. You can see the samples, they are densely oversampled, and the recovery is good, which is not so surprising. It's okay. But somehow we downsample the data, so you can see the data, they are sparsely sampled, but we can still have a very good reconstruction, the red one and the yellow one. And to show the real capacity of this algorithm, we downsample the data again by 3 times. In this level, we are somehow compared to the Shannon-Nyquist level, but the samples here, they are very sparse. However, the signal reconstruction is still quite good compared to this one, which is more or less the same level as the ADC resolution, to show the real capacity of the robustness and the accuracy of the algorithm. Thanks for listening.